Okay, this lecture is over Module 8 of the curriculum entitled SLAAC and DHCP version 6. These are two methods by which devices can get their IP version 6 addresses. So we'll start in 801, which I noticed a little inconsistency. It's simply entitled Welcome. Typically this is called Why Should I Take This Module? So like I said, a little inconsistency that I will report to the curriculum team at Cisco. But basically, the purpose is to learn about SLAAC protocol and DHCP version 6. These are both dynamic addressing protocols for IV version 6, just like we have DHCP, more accurately DHCP version 4, that we use for IP version 4 addressing. So what will you learn about in this module? We'll talk about how devices get their global unicast address, often abbreviated GUA. We'll talk about SLAAC, which is Stateless Address Auto Configuration. We'll talk about DHCP version 6, which is another way, like I said, to get an address. And then we'll talk about how you go about configuring a DHCP version 6 server. So 8.1 is talking about the global unicast addressed assignment. Just to refresh our memory, I think from Cisco 1, and we may have mentioned it here in Cisco 2. In the case of IP version 6, you have the global unicast address that we're getting ready to talk about, which is kind of like a public IP. And then we have a link local address, which behaves like a MAC address does in IP version 4 and is good for communicating on the local LAN. So what we're talking about here first is static or hard-coded configuration. So we're on a PC and we're in Internet Protocol version 6 as opposed to Internet Protocol version 4 or TCP/IP version 4, or sometimes in older Windows operating systems simply TCP/IP properties. So we can either get the address automatically or dynamically, or we can hard code it, which is what they're showing us here. So we said use this address. We then have to know what IP version 6 address this device is getting. We need to know the prefix length, which the majority of the time, the good majority of the time, in IP version 6 is 64. And then we need the IP version 6 address of the default gateway. And then we need to hard code a DNS server. So that's what we would do on a PC. The other way we can go about doing this is saying obtain an IP version 6 address automatically as well as the DNS. So we're going to talk about that, but that would be using the two protocols that this chapter is about, SLAAC and DHCP version 6. So as I just mentioned, in IP version 6, we have a link local address. So when we're doing that, there's three methods that can be used, and they're discussed in the upcoming sections. But this graphic, we did an IP config on a PC, and notice that it does have a link local address. However, it does not have an IP version 6 address and does not have a default gateway. The reason we don't have a GUA is that is usually set by the gateway router, and we don't have a gateway router, so it was not able to obtain an IP version 6 address. So the way a device goes about getting a global unicast address, which is a unique public IP address basically, you should have covered this in CIT 161. I'm thinking that maybe as long as you had it after December of 2019, this may not have been in the older CIT 161 curriculum. I don't remember teaching it until the spring 2020 semester. But basically, there are, at the top, two ways that we can get the global unicast address. We can do this statefully, which means the information came from a DHCP version 6 server, and that server is keeping track of the devices to which it assigned GUAs and what that GUA was and that type of thing. Or we can do this stateless, where there's really no device assigning that IP address, like in the case of a DHCP version 6 server. However, from the routers, it is able to figure out that information. So that's where SLAAC comes in. Basically, the router sends out a router advertisement, basically saying, hey, I'm a router. Here's some information about me, including network prefix, network length, default gateway, etc. And then what happens is the individual devices that need an IP version 6 address will then create one mimicking part of the router's IP version 6 address. Another way to do that is a combination of SLAAC with a DHCP server. This is basically DHCP version 6, but it's stateless. So the router advertisement provides configuration information and informs them of a DHCP version 6 server that they can contact for additional information. And then the host uses that router advertisement to create their own unique GUA, and then uses the other information from the DHCP server to set some of the other networking protocols. In the case of DHCP version 6, we'll talk about that, but recall that we have a four-way handshake in DHCP version 4. We discussed a module or two ago. We still have kind of a handshake, but the terminology is a little different in the case of DHCP version 6. So we talked about router advertisement, and there are three different flags that we talk about that are encoded in ICMP version 6. Again, ICMP is Internet Control Message Protocol. We talked about that in Cisco 1. Primarily where we talked about ICMP is the protocol that part of which we use for ping and trace route. So there is an ICMP version 6. So there is an A flag that basically says set your IP address. Your address is auto-configure. There is an O flag to indicate whether there is other configuration information coming from the DHCP version 6 server. And the M flag is a managed address configuration. So that's basically hard coding, which means a DHCP version 6 server gave us our global unicast address. So down here, they're showing the different ways. If there is a router solicitation, a router advertisement will be sent. These router advertisements are sent periodically, but in this case, the client did a router solicitation. The router that it's connected to responded back, and it can have different settings. If the A flag is 1 and the other flags are 0, then you're simply using SLAAC. Again, stateless auto address configuration only. This is the default. If we have the A flag set and the O flag set, then we're using a combination of SLAAC to get our address, and then using a DHCP version 6 server to get other information. And then finally, if we're doing stateful, that is simply, what I'm going to call normal DHCP, or the DHCP that's like IP version 4 protocol, the M flag, the managed flag, is going to be set to 1. So that's how the devices know how to get their configuration. 815 is to check your understanding on the assignment of the global unicast address. You can do that on your own, and we'll move on and talk about SLAAC. So again, it's a stateless service. That means there's no server keeping track of the IP addresses that are signed. Again, a host can send a router solicitation to get a router advertisement response. Again, we saw two situations a couple of sections ago where SLAAC can be used by itself, or it can be used in combination with a DHCP version 6 server to get other information. So, to enable SLAAC, we have a topology here. We have a router, we have its interface, we have its link local address, we have its global unicast address, and we have a PC, which presumably needs to get some IP version 6 addressing information. So the first thing here, verify IP version 6 addresses, is we're doing a show IP version 6 interface on G001, this interface up here on router 1. Notice it does have a link local address. It does have a global unicast address, and it is in some group addresses as well. To enable IP version 6 routing, we can say IP version 6 unicast routing, and that's all we need to do, again in global configuration mode. And then to verify that it's enabled, we can show the interface and just search for joined. And now notice that we have a new prefix down here that we are joined to, which means we did get a link local address. So the next one is talking about using SLAAC only method. Again, it is enabled using the IP version 6 unicast routing like we saw before. When we do that, all IP version 6 configured interfaces on the router will start sending router advertisements with the A flag set to 1. And again, the A flag set to 1 tells the client devices or end devices or even routers to create its own IP version 6 global unicast address. So when we do that, notice here we issue the IP config, and now we do have an IP version 6 address, and we also do have our default gateway set. So that means SLAAC is working. 824 is talking about those router solicitation messages. I told you that the client can either send those and then get a router advertisement response, or I told you that periodically routers are going to send out these router advertisements, and it does that every 200 seconds. Or as soon as it sees something from a device, a router solicitation. So that's showing you the process of going through and getting that router advertisement so that we can set our ID. So on a host, there are a couple of ways that we can set the global unicast address. So basically what they're calling here the interface ID This is what we would normally in IP version 4 call the host portion of the address. So there's two ways that we can generate that. What we would equate to the network portion, the first part of the IP version 6, that would be set to the same as the router that we have in our subnet. So what happens is it will randomly generate a number, and it points out that Windows 10 does that. It will randomly generate this interface ID. We also have something, I kind of like it a little better, called EUI64 process. And basically what happens is it takes our MAC address of the PC and it takes the first half, the OUI, the organizationally unique identifier. Again, should have learned about that in Cisco 1, regardless of when you had Cisco 1. Then you insert hexadecimal FFFE as the next part of the address, and then you take the last half, the last 24 bits of the MAC address, and put that on the end. And then that becomes the interface ID, or the interface ID. So looking here, I don't see FFFE anywhere. So this should have been a randomly generated, yes, they're saying that here, randomly generated interface ID. Now, MAC addresses are supposed to be unique. So if you use the UEI64 process, you should end up with a unique interface ID. However, more likely in the case of where you randomly generate that's a pretty big number, and it's unlikely, but there is a possibility that two devices on the same local area network happen to randomly generate the same interface ID. When that happens, we need to use something called duplicate address detection, which is written as DAD. Basically, what it's going to do is a host that is using duplicate address detection is going to send an ICMP version 6 neighbor solicitation with a special multicast address called a solicited node multicast. So basically what it's going to do is if you want a particular node to respond, you would send this solicited node multicast. And if the node's there, it'll respond. If it's not there, then it won't respond, obviously. So if you send a request using your interface ID in the request, you're basically saying, hey, I want to talk to a device that has the same interface ID as me. If you get a response back, then your address is not unique. That is, there's somebody else on the same local area network that has the same IP version 6 address as you do. And if that's the case, the host will immediately determine a new interface ID for itself. So that's duplicate address detection. 827 is a check your understanding on SLAAC. Of course, you do that on your own. And we'll move on talking about DHCP version 6. They talk a little bit, or maybe they don't, about ports, but I think it's important to mention, yeah, there it is. In the case of DHCP version 4, we use port 67 and 68. And in the case of DHCP version 6, we use ports 546 and 547. So there are a different set of ports so that DHCP version 4 and DHCP version 6 can coexist on the same network and even on the same machine because they're using different ports. DHCP version 6 can be either stateless or stateful. We discussed that in the previous section. What happens is the first step is the host sends a router solicitation, and then the router is going to respond back with a router advertisement. What's going to then happen is the client, which is now a DHCP version 6 client, needs to locate a DHCP version 6 server. So it will send a solicit message to the DHCP version 6 server, and it will return back with an advertise offering it an address, and then the PC or end device is going to send back a request to use that IP address, and then a reply is going to come back. So once we do the router solicitation and get some information from the router, we still have this four-way handshake with a DHCP server. It's just the terminology in DHCP version 6 is a little different than it is in DHCP version 4. Here we're talking about stateless DHCP version 4 operation. Basically, the router sends a router advertisement. It has the A and O flags set to 1. So that means we're going to use auto address configuration. So in that case, we talk to a DHCP version 6 server that is stateless. That means it doesn't record any information about the GUA or anything else about PC1. To enable stateless DHCP, we go in and we issue this command. This ND here, I don't know if they tell you exactly what that stands for, but that stands for Neighbor Discovery. So it's going to turn it on with the other config flag. And then if we look at that, notice it says the duplicate address detection is enabled. It tells how many times it's gone through and check that, and then gives you other information about the IP version 6 process. So that's stateless DHCP. If we move on to stateful, again, notice that the M flag is the only one set to 1. And just to refresh your memory, this M is for managed address. So what's going to happen is it is going to get the DHCP server address from the router. It is then going to make a request of the DHCP version 6 server. So how do we enable stateful DHCP on the interface? We go in, and for neighbor discovery we say managed config flag. So if we go and look at that, DAD is enabled even though we're getting this from a DHCP server, and it says host uses DHCP to obtain routable addresses, which is a global unicast address, just like public addresses in IP version 4. So A36 is a check your understanding over DHCP version 6. And we will move on to talking about how we configure a DHCP server. So there are 3 kinds of server roles that we can have. We can be a server, which is somebody who is giving out and keeping track of IP version 6s and clients. We can have a DHCP client, which is a device that has gotten its information from a DHCP version 6 server. Most of the time we think of that being an end device, such as a PC or a phone, but in the case of DHCP version 6, it can actually be another router. And then we'll talk about relay agents, which is when a DHCP version 6 request needs to be forwarded because the client and server are not on the same network, as we often see in the examples in the curriculum. So here we have a setup. Notice we have a router that is running DHCP version 6. That might be the other thing that's a little different. Most of the time when we talk about IP version 4, or I'm sorry, DHCP version 4, that will be running on some type of computer, maybe a server. Here it's running on a router. We do have a PC that can be a client to this DHCP server, but we can also have other routers that are clients to this DHCP version 6 server as well. So to enable IP version 6 routing, first thing we need to do is issue the IPv6 unicast routing command. The next step is to configure a pool name. So in this case they called it IP version 6 stateless. We can go in and configure our DNS server for it to give out. We can configure a domain name for it to give out when it gives a DHCP version 6 response. We can then bind the DHCP server to an interface. So here we have the DHCP server and its pool, and since we're in interface gig 0/0/1, that is the interface that we're going to bind to, or the interface that we're going to send information out. And then finally the last step is to verify that we are getting information. So we're here on a PC, we do an IP config/all, there's our domain name, DHCP is enabled, we have an IP version 6 global unicast address, we have a link local address, and we have the DNS server that we specified. So here we can see that the information we are getting is valid, and notice that this is a client ID that is assigned to it. So that verifies that IP version 6 is working. So how do we configure a stateless DHCP version 6 client? In this case, the client is another router. So we do have to turn on IP version 6 routing. Same command we saw before, IPv6 unicast routing. The next thing we would want to do is go in and create a link local address. Basically, when we enable IP version 6 on an interface, it will do that. We then set the IP version 6 address to autoconfig so that it will use SLAAC to get its address. We then go in and look at show IP version 6 interface brief to verify that indeed we did get, we have a link local address and we have a GUA as well. So we verified that it's working. And then we can go through and on that client router show information on gig 0/0/1, and it will tell us that it is in client mode, and then tell us here's the DNS server, etc. So that verifies that the client router, or the router that's a client of the DHCP version 6 server, did pull information or receive information from that DHCP version 6 server. Now then, if we want to do this and do this statefully, where we keep information about the devices, some of the steps are the same. The first step is IP version 6 unicast routing to enable IP version 6 routing. The next thing we need to do is create a pool. We then need to set an address prefix for clients. We need to tell it a DNS server. We need to tell it the domain name that we're using or that we're part of. And then we need to go in and pick an interface, and then go in and for neighbor discovery we have managed config flag that we talked about before to turn that on. Then we tell what pool we're using to give out IP addresses, and then we say no shutdown to bring the interface up. And then the last thing we need to do is again do an IP config/all to verify that it got its domain name, an IP version 6 address. Notice that it also tells when we got our lease, when that lease expires, our link local address, and the DNS server. So yes, we did from this stateful DHCP version 6 server get an address. So that's configuring the server. How do we configure a client? Again, our client is another router. IP version 6 unicast routing to enable IP version 6 routing. Then we enable IP version 6, which will create a link local address. We then tell it IP version 6 address DHCP, so we're telling it how it is going to get its IP version 6 address. We can then use show IP version 6 interface brief to show that it did get an IP version 6 address. And then the last thing is we can show DHCP interface G001. And again, we're looking for things like it's got its domain name, it has its address, it shows the lease in a slightly different way, but it got a lease from a DHCP server, and it tells you how long until it's going to release and attempt to renew that address. Okay, as far as verification commands on the server, there are a couple of things you can do. Show IP v6 DHCP pool. It will tell you the pool name. It will tell you the prefix. Again, most of the time this is going to be a /64. It tells you what the DNS server is. It tells you what the domain name is. And this active client 2 means that there are 2 devices that have requested IP version 6 address information from this DHCP server. If you list the binding, it's going to tell you here's a client, here's information about the client, what address it got, about its lease, and here's another client. So this presumably is the same router as in this one where it said active clients 2, and this is going to actually give you information about the clients. Okay, a relay agent. So DHCP is basically, in version 4, it's like, hey, here's my MAC address. Does anybody know anything about me? Here it's going to be looking for a DHCP version 6 server. And the problem we have is this is broadcast based. And if you recall, routers segment broadcast domains. So when this client is trying to contact the DHCP server, it will only do it for things that are in the local area network on this interface G001 of the router. It's not actually going to get a message to the DHCP server. So what we do is routers that have end devices that need to talk to the DHCP server, we can turn on IPv6 DHCP relay, and then we can give a destination for where our actual DHCP server is. So here they're showing going in and setting up this relay host to talk to this server. So what happens is when there's a DHCP request in this network or any other network attached to this router, it knows to talk or forward that request to the router running the DHCP version 6 server. Now then, to verify that this is all working on router 1, which is this router, you're going to go through and say show the interface, and it's going to say it's in relay mode, and here's where I'm relaying to, and out what interface I need to go out to get to that IP address. We can show the binding, which again in this case we have one client. It will give us the address and lease information, so we're sure that things are talking to it. And then finally on the PC we can do our IP config/all and see again that yes, we got an IP version 6 address, we got a DNS server, we got a domain name. So that shows us that the DHCP version 6 relay agent is working correctly. So the next section, 849, is to check your understanding over the things we just talked about with the DHCP version 6 server. You can do that on your own, and we'll move to the module practice and quiz. So it starts out with a lab, which again is usually on physical equipment. I need to look at this. There's I guess actually three possibilities. One possibility is I will not assign this at all. That's a semi-low probability. We may do this on the NetLab, or I may have you go into Packet Tracer and quote wire the topology up yourself and actually do this within Packet Tracer. So starting from scratch doing it. So whenever I decide if and how I'm going to assign this lab, it will appear in Blackboard. What did you learn in this module? So you can read that on your own. That's all the important highlights that we talked about in this module. And then of course we finish up with the module quiz on the entire module, which you can do on your own. And that finishes up Module 8.